My name is Gary Fahnensteil. I'm a senior ecologist for NOAA, the National Oceanic Atmospheric Administration, specifically with Great Lakes Environmental Research Laboratory. We're here in beautiful southern Lake Michigan, just off the port of Muskegon, Michigan, collecting samples aboard the RV Laurentian. Zebra mussels were the first dry-seeded mussel into the Great Lakes, and actually they became established in the 1980s. Particularly, I think, first Lake St. Clair, Western Lake Erie was just huge populations were established. And then they spread throughout the rest of the lakes. In Lake Michigan, zebra mussels were established in the early 1990s, and by the late 1990s had large populations. But in the upper lakes, Lakes Michigan, Lake Huron particularly, zebra mussels were primarily found around the edges of the lake because they need warm water to reproduce and they need hard substrates, okay? And that's limited in southern Lake Michigan and the lake. So they had basically a limited distribution. Well, in the late 1990s, quagga mussels became established in Lake Michigan, in Lake Huron, and they just basically took over. Now they're cold water adapted and can grow on soft substrates, so perfectly adapted for these cold water deep systems. And so they basically became abundant all the way across the lake, not just in a nearshore ring. So you could go from Lake Muskegon, where we are here, across to Milwaukee 80 miles, and right now almost walk on a carpet of quagga mussels. And the densities of quagga mussels you might think about are approximately 1 to 10,000 per square meter. So huge densities. In the last few years, they've filled in all the deep holes in Lake Michigan as well as the nearshore region. So just pretty much all the way across the lake. And the big surprise is that it's hard to find a zebra mussel in Lake Michigan today. Even though there were thousands, millions in the lake in Lake Michigan in the early 1990s, now 99% of the mussels that you would find on the beach or anywhere lake are quagga mussels. Just 1 out of 100 in Lake Michigan would be a zebra mussel. In Lake Huron, it's more 5 to 1 quagga mussels to zebra mussels. A year ago, they were all talking about 900 trillion and stuff like that. Now we passed that 1 quadrillion mussels in the lake, and it's just a huge number. When you think about the densities that we have collected, and you have a few of them on picture today with a ponar, but 1,000 or 10,000 per square meter, and you multiply that to a lake that's 80 miles long and 300 miles wide, it's just phenomenal. The changes in Lake Michigan in the last few years have been truly historic and phenomenal. Lake Michigan in the last few years have had water quality characterization parameters similar to Lake Superior in some of the clearest fresh water on the planet. Do I have a sucky disc here somewhere? If you look at this sucky disc, and you have to realize that the mussels population were affecting the food web, the phytoplankton, primarily when the whole water column is linked to the bottom. In Lake Michigan, we go through a period from around Christmas time to around June 1st, where the whole lake is isothermal mixing top to bottom. And during that period, everything in the water column can be filtered by mussels on the bottom, even when the water column is 100 meters deep, like we were out here earlier this year. So basically, they can affect the whole water column. Once the lake stratifies, usually around June, until that Christmas time, the mussels are cut off. So we see the big effects of mussels on Lake Michigan water quality, food web, and like during that winter-spring mixing period. And to give you an example, in the 1980s or 90s, if you would lower this white disc down to the bottom, you would see it down about 20 feet, then it would disappear. Well, this past couple springs, we have put this thing down over 100 feet below the surface, and you can still see it. In fact, like I said, some of the clearest fresh water on the planet was in Lake Michigan the last couple springs. And so basically the mussels are just removing everything from the water column, putting it down on the bottom. So we've seen substantial decreases in phytoplankton productivity, abundance, zooplankton, everything in the water column is now pretty much associated with the bottom. So huge changes. And like I said, the big thing, and one thing we noted in the paper, is that Lakes Michigan and Huron now look like Lake Superior in terms of water quality characteristics and parameters in the lake. Okay, that's fine. Yeah, I was just demonstrating. This thing is typically, it's called a sucky disc. This is an oceanographic disc, and you lower this down to where you don't see it anymore, and then you bring it up to where you see it on the shade side of the boat, and that's basically a sucky disc recording. And the nice thing about them is they've been done historically. Obviously, we have more sophisticated instruments today to characterize the optical properties of light, but the nice thing about these is they've been recorded for decades. Okay, and in Lake Michigan, again, as I mentioned in the spring, you'd put this thing down 5 to 6 meters and it would disappear 20 feet or so. Okay, and that was typical for the 80s and 90s. Now you could put this thing down over 30 meters, over 100 feet of water before it would disappear. Just this typical gin clear water, you would call it. It was phenomenal. And like I said, that's getting to some of the clearest water recorded in interfresh water. And so the mussels just took everything out of the water column. I think the changes that are occurring in the Great Lakes are historic, not only in terms of the intensity, but for the frequency of what the duration of what they occurred. Some of these occurred in 3 to 5 years. Huge changes. And really what mussels have done, whether you're in Western Lake Erie or Saginaw Bay or Lake Michigan, Lake Huron, they have re-engineered the system. Re-engineered it spatially and temporally. How everything is processed and moved around is totally changed. For instance, as I mentioned, much of the action now, rather than being in a water column, historically 90% of the production would be in a water column. Now it's mostly associated with the bottom and secondary production and stuff like that. So you really see this, the conveyor belt effect down to the bottom. But also as things move in horizontally, they've had huge changes. They basically retain much of the nutrients around the near shore region. And we're seeing a lot of near shore problems that we would call eutrophication problems that basically we thought we had gone away, now reoccurring because the mussels are retaining that phosphorus and those nutrients in those near shore region. A prime example is Saginaw Bay. Saginaw Bay, Lake Michigan, is a eutrophic part of Lake Huron that had pretty good fisheries, used recreationally, but kind of eutrophic. And we had a lot of algae blooms in the 60s, 70s, and even early 80s in Saginaw Bay. They went away by the late 1990s, but they reoccurred in the last decade. Okay, and that's related to the mussel populations. And what we found is that the mussels are retaining the phosphorus in Inner Bay. The big source of phosphorus to Saginaw Bay was the Saginaw River. 90% of phosphorus would come in the river, mix in the bay, and then be transported off to Lake Huron. Well, now because you have these huge mussel populations, they're retaining twice as much phosphorus near shore and in the Inner Bay. And so even though you're reducing the inputs of phosphorus, you're still having these problems because it's not moving offshore like it used to. So that's the whole idea, re-engineering, just changing everything. I mean, fundamentally, the system is just not functioning anywhere like it did in the past. So you can look at bulk properties, but you also realize system re-engineering has just changed the whole lake as well. The fisheries impact of the Dreisenids on the Great Lakes obviously is mixed. Some species have done well, some have not. But either directly or indirectly, the Dreissenid expansion has been linked to the collapse of salmon in Lake Huron and the demise of many sport fish, particularly, as you might expect, those that are dependent on planktonic food. Okay, that are dependent on zooplankton, phytoplankton, planktivorous fish like alewife. Those species have not done well. The salmon, the whitefish, and the like. Species that are adapted and can feed on the bottom, such as perch and walleye, have done well. Smallmouth bass have done well around Western Lake Erie. So if you're more omnivorous and you can use benthic food, you have done well. In fact, Western Lake Erie, Lake Huron, after the collapse of salmon, walleye have come back substantially all throughout the northern part of Lake Huron as well as Saginaw Bay, because they can really now do well, not only the mussels, but then they brought the goby as well. We have a lot of round gobies in the Great Lakes as well. In fact, some have estimated that 10 to 20% of the fish biomass in Lake Michigan now is round goby, and they're on the bottom and really changed. So you really just had what we call the benthification of Lake Michigan food web, and it's been a huge shift with that re-engineering, but it's changed the fishery. Those species that have been primarily planktonic have had problems, very significant problems. So the temporal issue is a big thing. You know, what happens now? We have these huge expanding populations, high densities, and we know from the zebra mussels, okay, that they collapsed. And if you look at Western Lake Erie, Saginaw Bay today, the population of zebra mussels that are there are 1/5 to 1/10 of what they were, you know, for the big expansion. Now, quaggas are different, okay? They can live a lot longer. They're cold water species, and so they may just basically slow down their growth rate, okay, and live 15, 16 years out here and still filter at a much lower rate. And that's a real issue. So the question is, are they going to collapse or just slow down and grow more slowly? If they don't collapse, they will have probably the ability to keep things very low and starve the system for a long period of time. But if they collapse, they'd be more like the zebra mussels and quagga mussels. And that's really the million-dollar question right now in the Great Lakes is, where do we go from here? Are these mussels, the quagga mussels, population is going to collapse? And see what we're seeing a little bit, Tom Nalepa's seeing, as they're starting to filter out everything in a water column and starve themselves, they're basically, their fecundity or the reproductive rate's going down, but they're growing a little bit slower, but the biomass has stayed about the same. So you're shifting from high fecundity, a lot of little ones, to just more bigger ones that are growing slower. So there's really been a shift, but it's going to be interesting to watch that as we go forward from here. So, well, the thing we've learned from the Great Lakes is, and I'll give you the prime example, Lake Ontario. I can remember coring in Lake Ontario in the early 1990s, I think 1992, and we cored out in a deep basin of the lake. And this is when zebra mussels were here, but not quagga mussels, okay? And we cored out there, and we saw these mussels on all the mud, and we couldn't figure out what they were, and they were quagga mussels. But it took over a decade or even almost 2 decades before the effect of quagga mussels were found in Lake Ontario. So it can take a long time. That's at the base of the food web. The fisheries effects can take a long, long time, and it's really difficult to say. I mean, part of the reason why some species have done so well under mussels is to reduce competition for the available food, for the ones that are gone, okay? So it's really difficult to say what the fishery is going to look like long term in any place, but I mean, it's not good. I mean, I don't think anyone should argue that or would believe that if you have these huge mussel populations, our fisheries overall is going to be beneficial. There are small segments that might do better, but overall it's going to be not good, and that's the problem. Because what you're doing is you're just putting most of that carbon energy into mussels, which you'd like to put into fisheries. In Lake Michigan, the estimate right now is that there's 4 times as much drycenid biomass as there is fish biomass. And that's the problem. And so any way you cut it, yes, you might have one very little one species doing well, but overall, that's the disaster for the harvest and sustainability system. When I was out here early 1990s, when they were first found, Dave Jude found them from the University of Michigan. I had to put that plug in them because I was just picking Petoskey stones with him the other day. So, but he found them, and they were mostly near shore. In fact, we used to have tournaments in Muskegon, I loved them, called Goby Dick tournaments, where you try to catch the biggest goby. They just sponsored them to get everybody to get rid of them. So we'd fish all over, and all the Sportsman's Club would sponsor them. It was just a great idea. And they were all near shore, on the piers, Muskegon Lake and stuff like that. Well, as the quagga mussels established themselves offshore, in these high densities offshore, the round gobies moved offshore, and they've moved out now to 450, 500 feet, have large populations. They just followed their food out, okay? And they're, like I said, the latest estimate is somewhere between 10 to 20% of the fish biomass in Lake Michigan now is round gobies, just phenomenal. So not only do you have more drycenids in all fish, the one fish you got is one that people don't really even like that much. But it's a benthic species, so it really promotes that benthic food web and the benthification of the whole ecosystem. In Lake Michigan, the round goby, because it's expanding, it has definitely competed with the yellow perch, which is a prime game fish. But also there's another species, the deepwater sculpin, which was a food for lake trout and a lot of other species, as well as being affected by the goby because it's just moving in. And it certainly is competing with, and the yellow perch is one of the primed fish around here. In fact, I would argue yellow perch is the best fish to eat in the world, and you have to eat it before you leave here. Forget all that marine stuff. The sweet yellow perch, Perca fulvescens, the best. And what's happened, okay, because you've retained a lot of these nutrients near shore, you've had a lot of increase in nuisance algae biomass other than phytoplankton because it's no longer in the water column. In the Great Lakes, we don't have a lot of macrophytes unless you go very short, and that's just because there's so much energy turbulence in that near shore region. They just can't root and grow well there. So we have a lot of attached algae, benthic algae like Cladophora, big problem in many areas of the Great Lakes. In fact, it has been estimated now in Lake Michigan, if you went to the zone where Cladophora could grow, 25% of that zone now has significant Cladophora beds. Okay, a huge nuisance green algae on the beach. People don't like it. It's a problem because the nutrients are now being trapped near shore, and you have increased light, these benthic algae are just growing all throughout the Great Lakes. The other problem that we're seeing, another eutrophication effect. You realize all these are related to the eutrophication effect that we had in the 70s, 80s, and everybody thought was gone. But now because the mussels are retaining those nutrients there, we're seeing all these nutrient problems. Cladophora. And then we have harmful algal blooms. Actually, a toxin producing cyanobacteria, microcystis, is becoming very abundant in the Great Lakes. In those areas that are shallow and eutrophic, Western Lake Erie, Saginaw Bay, Green Bay, we're having large blooms of microcystis that we haven't seen for 30 years. And so, or at least 20 years or so. And so they've come back in a big way, in a big vengeance, since about 1995 in Western Lake Erie and about 2000 in Saginaw Bay. And it's again just because the nutrients are being available to other algae. And these algae, basically nuisance algae, grow on the surface and cause a real problem. The problem you got to remember in the Great Lakes, over 40 million people get their drinking water here. Okay, so it's a big deal for drinking water, not only the beaches and stuff like that. And so the toxin is a microcystin produced by the genus Microcystis, is a hepatotoxin, affects liver functioning. So basically, you want to keep it out of the drinking water. You want to, you don't want to ingest it when you're swimming and stuff like that. So it's a big problem on bathing beaches and by water intakes. And so they're very much concerned about it throughout the Great Lakes. And I should point out, the abundance, the increase of these harmful algal bloom has been directly linked to the selective filtration of drycenids. Okay, no doubt about it, is that these Dreissenias process a lot of water, whether it's quagga mussels or zebra mussels. And as they do, these big, large nuisance colonies, these harmful algae like Microcystis cyanobacteria, are thrown out as pseudofeces. And so over time, these mussels remove all the desirable algae, and they really enhance the undesirable algae, the harmful algal bloom, so their abundance increases tremendously. And that's the direct effect that we've seen. And so then you throw in nutrients where you got to have some kind of plant biomass, and now you're really favoring these harmful algal blooms. They just explode and they become a big problem. And because of the cladophora and the harmful algal blooms and the mussels, we have avian botulism going through the roof in many parts. Dead birds all over, loons in northern parts of the lake, all attributed to the mussels. So it's really been a mess. And I think all of us would say not a good mess, the mussels. I mean, to the people of the West, you do not want these in your lake, period. End of story. Now, somebody that might be in a turbid, like little lake, a deep water, said, oh, well, they're going to clear it up. Yes, they're going to clear it up, but you're going to have all kinds of nuisance problems like we're seeing here with harmful algal bloom, cladophora, nearshore stuff's attached. There's just nothing you do not want. And I really applaud the West for the way the attention they're putting on prevention and keeping the boats out. That's the way to go. You spare nothing to keep these mussels out of your lakes, absolutely.